The deadly Vaiont Dam disaster. A geotechnical perspective. Welcome to Blueprint to Reality, the channel where we unravel the engineering stories behind some of the world's most impactful events. Today, we're exploring the Vaiont Dam disaster, a catastrophic event in 1963 that claimed over 2,000 lives. Let's delve into the geotechnical failures behind this tragedy and uncover the critical lessons learned. The Vaiont Dam, an engineering marvel turned tragic. The Vaiont Dam, located in northern Italy, was one of the tallest dams in the world at the time of its completion in 1960. Rising 262 meters, the dam was an engineering marvel designed to generate hydroelectric power. However, despite its structural integrity, the disaster occurred due to a massive landslide into the reservoir, unleashing a deadly wave of water over nearby villages. The geology of the Vaiont Valley. The Vaiont Valley's geology was inherently unstable. The mountains surrounding the reservoir were composed of stratified limestone and clay layers. These materials, combined with the steep slopes, created conditions ripe for landslides. Geological surveys conducted before construction had noted potential instability, but these warnings were underestimated. The role of reservoir-induced seismicity. The filling of the reservoir introduced additional stress on the already unstable slopes. Water infiltrated the rock layers, increasing pore pressure and reducing friction along existing faults. This phenomenon, known as reservoir-induced seismicity, played a significant role in triggering the catastrophic landslide. The night of the disaster. On October 9, 1963, a massive 260 million cubic meter landslide plunged into the reservoir at speeds of up to 110 kilometers per hour. The displacement caused a wave over 250 meters high to crest the dam, devastating the villages of Longarone, Perego, and others downstream. The dam itself remarkably withstood the event, but the human and environmental toll was immense. Failure to heed early warnings. Signs of instability were evident long before the disaster. Cracks and minor landslides had been observed in the slopes, and experts had expressed concerns. However, these warnings were either ignored or inadequately addressed, largely due to economic pressures to maintain the dam's operation. Geotechnical lessons learned. The Vaiont Dam disaster underscores the importance of understanding and respecting geological conditions in large-scale projects. Comprehensive geological surveys and ongoing monitoring are essential, especially in regions with complex geology. Engineers must also account for the dynamic interactions between human activities, such as reservoir filling and natural systems. Modern approaches to prevent similar disasters. Advances in geotechnical engineering have significantly improved our ability to predict and prevent such disasters. Slope stability analysis, real-time monitoring of reservoirs, and early warning systems are now standard practices. Engineers also use controlled reservoir filling and drainage techniques to minimize stress on surrounding slopes. The legacy of the Vaiont disaster. The Vaiont Dam disaster remains a sobering reminder of the power of nature and the consequences of neglecting geotechnical considerations. It has since become a case study in engineering ethics and the importance of prioritizing safety over profit. By learning from this tragedy, modern engineering continues to evolve to safeguard communities against similar catastrophes. Thank you for joining us on this exploration of the